questions? All right, solving radical equations. So to start with, we're just going to solve this equation, right? It's actually a quadratic equation. 4x squared minus 32 equals 68. So the easiest way to solve this is to isolate the x, and to do that, we're going to add 32 to both sides, giving me 4x squared is equal to 100, right? 68 plus 2 is 70, plus 30 is 100. And then we want to isolate the x, right? Because that's what we're trying to solve for. So we're going to divide both sides by 4. So x squared is 25. And now, how do we get x? You square root. But when you're solving a quadratic, it's important that you take whatever. So what squared gives me 5? Or sorry, 25. 5. Or what else squared gives me 25? Negative 5. So the answer here is plus or minus 5. When we solve a quadratic, there will be two answers for x, right? If you graph that, 4x squared minus 32 as y1 and 68 as y2, look for the end, there'd be 1 at 5 and 1 at minus 5, right? So the important thing here, though, is just any operation performed on one side must be performed on the other side as well, right? That's how we keep it an equation. We do the same thing to both sides. A radical equation, all right, so it's today's thing, right? We want to be able to solve radical equations, has the unknown variable as part of the radicand. That means the variable's under the radical sign. So, which of the following are radical equations? Is the first one a radical equation?
Yes.
Yes. Is the second one a radical equation?
No.
Why not?
The x is not under.
Yeah, the x is not under the radical sign. So this one is not, because the x is not under the radical sign. And what about the last one? It is.
Whoa. Well,
Okay, what's next? Sounds like an answer. State the restrictions for each of the following equations and then solve the equation. So, with radicals and solving radical equations, very important that you state restrictions. Okay? And because when we go to check the answer, we need to see sometimes what we're going to do to solve a radical equation is get rid of the radical sign. How do we do that? Multiply by the radical itself. Yeah? Or we square both sides, really, right? We isolate the radical, so here's the whole key. We're going to isolate the radical, get it by itself, then square both sides, and then solve. But sometimes the act of squaring both sides introduces solutions that aren't really a solution to the original. So we have to do two things. We need to be aware of restrictions so that we can eliminate some answers based on restrictions. And we also need to verify our solutions because sometimes we get a solution that isn't really a solution. It's called an extraneous root. Okay, what do we got? So state restrictions and then solve the equations, write your answers as exact values. Okay, so what's the first step to solve this? I'm going to do to both sides. Divide by 2. Divide by 2. So the idea is isolate the radical. What the government's trying to do when they put down an insurrection. Isolate the radical. Then what do we do? Square both sides. Okay, when I square the square root of x, what do I get? X. And when I square 5, what do I get? 25. Okay, now I know the worksheet says something about verify the solutions. What we're going to do is, later on it's asking you to verify. I'm going to verify every solution. Okay. And the reason is, when you solve radical equations, you have to verify every solution. So we think the answer is 25. Let's just take a little bit of space. So the left side of the equation is 2 root x, and the right side is equal to 10. And so what I'm going to do is substitute in the value that I think. I think x is 25. What's the square root of 25? So we have 2 times 5. What's 2 times 5? 10. Okay. So that solution checks. Okay, so I'm doing the checks now, so later on, in the sheet it says, now check this, we're gonna check everything as we go. Okay, root of 4x minus 20 is equal to 0. What's first step? Add 20 to each side, right? Isolate the radical. Okay, now what? Okay, we can't divide by 4 because that's not really a 4.
Get rid of the square root.
Get rid of the square root by doing what? Squaring both sides. Okay, what do we get when we square this? What do we get when we square this? What do we do to solve? Divide by 4. What do we get? Okay. Now there's an alternate way you could do this, right? You could have, let's go over here, we got a little bit of space here. Could say I've got root 4 root x minus 20 equals 0, or 2 root x minus 20 equals 0, right? Because the root 4, that can be pulled out, right? And you just say that's 2 root x. And then you would add 20 to both sides. And then you would divide both sides by 2. And then you would square both sides. Okay, so that's an alternative solution, right? Is that I could recognize, hey, I've got root 4x. But I could write that, I could write that as, I don't think so. Get out a piece of paper and write it down. Okay, now let's verify this. The left side is the square root of 4x. The right side, minus 20. The right side is equal to 0. So it's the root of 4. X we think is 100, which will be root 400 minus 20. Now remember, when it's the radical, you're taking the square root. It's the positive square root only, right? It's not like solving x squared equals 25, then x is plus 5 or minus 5. When it's root 400, it's just the positive root. So it's 20 minus 20, which is 0, and that checks.
Oh, that's cool.
Oh, wait, we're also supposed to state restrictions, right? Forgot restrictions. So what's the restriction on this? What does x have to be, or what can't x be?
Greater than or negative.
Okay, so it's got to be, so x has to be greater than or equal to 0. Right? And we got 25, we said, okay, that's okay. That solution might be okay. You know, we won't reject it out of hand, but maybe it isn't. On here, what does x have to be? Greater than or equal to 0. Over in C, what does x have to be? Okay, here, let's go up here, let's do it here. So we know that x plus 7 over 2, the expression under the radical sign has to be greater than or equal to 0, right? So how do we solve this? We're going to multiply both sides by 2. So x plus 7 has to be greater than or equal to 0. And then we'll subtract 7, so x is greater than or equal to negative 7. So that's your restriction, right? As long as x is above, bigger than, or equal to negative 7, you're okay. If it's below negative 7, you'll end up with a negative under here. You can't have that. So if we get any solutions and they come out as like negative 10, then we would just reject that solution, right? Just no, it doesn't fit. Okay, how do we solve this one?
Multiply it by 2.
No, we need to isolate the radical. So you could say the radical is isolated, right? Have a radical, it's all by itself. That's all that's on the left side is a radical. How do we get rid of the radical sign? Square both sides. Okay? So the idea is isolate the radical. So in this case, add 20 to both sides. The radical is isolated. Here, divide both sides by 2. The radical is isolated. In this one, the radical is isolated. So now you square both sides. So that gives me x plus 7 over 2 equals 16. Okay, now what do you do?
Multiply by 2.
Yeah, multiply both sides by 2. And then subtract 7, we get x equals 25. 25 is greater than or equal to negative 7, so we don't reject it out of hand, right? But we still need to check. So the left side is equal to the root of x plus 7 over 2. And the right side is equal to 4. Close. Sometimes I know how you feel. I never know what day is what. If it doesn't say specifically to check in a question on the test, you should still check, but you can do it in your head, right? So you can just sort of, okay, 25 plus 7 is 32, divided by 2 is 16, the square root of 16 is 4, this works. Okay, so if it doesn't explicitly say, you should still do the check, you could do it mentally. Same thing here, right? Think what, x is 100, 4 times 100 is 400, the root of 400 is 20. 25, root 25 is 5, 2 times 5 is 10. Right, so that's sort of what I say a quick mental check, or just throw it in your calculator. Here we're doing an explicit check. So we're actually going to substitute it in. So 25 plus 7 over 2. We don't bother with the right side, right? It's 4. We don't have to substitute in there. So this is the root of 32 over 2, which is root 16, which is 4, and then that checks. Okay, so every time we solve a radical, well, even rational too, but every time we solve a radical equation, we have to check the answer. Okay, we need to state the restrictions as well. Okay, next. Or is this next, or was there some on that? Yeah, just move. There. Okay, now moving on. D. Okay, what do we do? We got to isolate the radical. What do we have to do to isolate the radical? The radical is isolated, right? So we're going to square both sides. Okay? So the radical, right, it has an expression under it, but wait, what does that tell us? X has to be what? Greater than or equal to positive 5, right? So that's the restriction. We know that X has to be greater than or equal to 5. Yep.
Why is it already isolated?
Was there anything else happening? Is it multiplied by anything?
No.
Is anything being added or subtracted to it? Is it over a number? The 5, where is the 5?
The 5's under.
It's under the radical sign.
So what does that mean?
So that's not isolated. I got to get rid of the 2. That's not isolated. I would have to add 7 to both sides. That's isolated.
Why?
Because all that's there is the radical.
If there's a 5 there.
Doesn't matter. It has an expression under it. Here, this is a radical. That's a radical. If I'm going to solve an equation with that, I'm going to square both sides. Okay? So as long as it's under the radical sign, then it's isolated. If it's outside of the radical sign, right, or if there's something else going on, so let's just flip back. So if there's something outside of the radical sign, if there's something else going on, it's not isolated.
Okay.
This one is isolated though, right?
Okay.
Okay? So what you want to get it to, the point is, I need it at the point where all I have is the radical sign on one side and I have a number on the other side. Okay, so what do? And what do we get? 9. Okay, then what do we do to solve? Add 5. Okay, let's check. So this is equal to the square root of 14 minus 5, which is square root 9. And what's the square root of 9? 3. So what do we say? Doesn't check. So here's the deal. Here's the hint, the clue, the big takeaway from this question. If you have a radical and it's equal to a negative, it has no solution. Because the radical sign means the positive or principal square root, right? It means that whatever number you put in for x, you're going to get a positive value, and this is negative, and you can't do that. Okay, so you can, at this point, you could just write in and say, since the radical, which must always be positive, is equal to a negative, there is no solution. Okay, so for a solution, we just say no solution. Fancy way to say no solution. Just put it, that's called the empty set. It'll come in handy in 30-2. So the empty set uses brace brackets and then like a 0 with a slash through it. It's known as the empty set. Okay, continuing on. Or sorry, were there any questions on this one? Okay, now we have a cube root. The radical is isolated though, right? So what's the restriction if it's a cube root? Can you do the cube root of a negative? Yeah, so there's no restriction, right? X belongs to the reals. It doesn't matter, we can have a negative under a cube root sign because you can do the cube root of a negative. How do I uncube root? I cube it. Very biblical sounding. Cube it. And what do we get on the right hand side? 27. And what's x? 28. Okay, let's check. So on the left side, we have the cube root of x minus 1. On the right side, we have 3. So, 28. So remember, you need to check every answer. You don't necessarily need to do it formally though, right? But you do need to check it. So on the test, if you're asked to solve and you get something like D, right, where there's no solution, then I'd like to see you write down x equals 14, and then you can cross it out and just write no solution. And you don't have to justify that check. So if it says solve and verify, then you do have to show it. If it just says solve, you don't need to show the verification, but you do need to reject a solution that isn't a solution. Okay? So that's the important part. Okay, isolate the radical. How do we do that?
It's already isolated.
It's already isolated. That's what I was looking for. So what do we do then to solve? Square both sides. Okay, how do we solve this? Multiply both sides by x, right? Because you got to get rid of the x on the bottom. So 9 is equal to 16x. So what's x equal to? 9.
Divided by 6.
Oh, and what can't x be? Okay, so restrictions. X has to be greater than 0, right? It can't be 0 because you're not allowed to divide by 0, right? We can't do 9 divided by 0. It can't be negative because then 9 divided by negative would be a negative, so it can't be negative. So it has to be greater than 0, but not equal to, right? Just greater than. Okay, if we want to verify that, the left side. And then the right side, what's the right side equal to? 4. Okay, so if you're doing a formal verification, that's the word you're going to show. To do the 9 divided by 9/16, just do it in your calculator. Right, just go 9 divided by bracket, 9 divided by 16, bracket, enter it, it'll say 16. Okay. I'm not going to go with the whole, okay, 9 divided by 9/16 is 9 times 16 over 9, right, and then you cancel. You can just use your calculators to do that.
Okay.
Okay, and it verifies we got the 4. Go up this far. Okay, so think about what you do when you're solving. It's the only time you're going to get a value for x, right? Like the rest of the unit, it's all simplified. Expressed as an entire radical. Expressed as a mixed radical. The instructions on most of those are like simplify. Simplify means take an entire radical, express it as mixed radicals, add them together, right? We can do adding and subtracting. If we're multiplying, the instruction is still simplify, right? You multiply it out, you come up with a simpler expression, but not a value. The only time you get a value for x is when you have an equation, right? It's equal. And then you will see the word solve, right? Which is find the solution. If you don't see solve, you should not have an answer that says x equals 2, right? You don't get x equals 2 when you're multiplying root x times 3 root x or something. Right? You cannot solve that. Okay, verify the solution to 3 equations. We already did that, right? Okay, and we did these, right? Yes. I think those should say 3b, c, and d, not 4b, c, and d. Okay, been there, done that. When both sides of an equation are squared, sometimes solution occurs that are not valid in the original equation. These types of solutions are called extraneous roots. Therefore, it's important that all solutions are verified in the original equation. Okay, so you got to plug it back in. If it's, some of the questions on the test may explicitly say solve and verify. Then you have to show it. If it just says solve, you still need to do a verification so that you reject any solution. If it's a multiple choice and it says solve, you can be guaranteed we're probably going to give you, the solution will be, the solutions you'll get will be like 0 and 2 or something, but the only valid solution will be the 0 or the 2. So you need to check that, right? Don't just look at it and say, hey, I got 0 and 2, and there's the 0 and 2. It's like, wait a sec, my restriction was that x had to be greater than or equal to greater than 0. I can't use the 0 here, it's only a 2. Okay, so be suspicious. Verify solutions for the rest. Okay, we already did that. State the restriction and then solve each of the following. Okay, so this is kind of upping the ante a bit, right? There's a lot to do here. You take it one step at a time. It's not as bad as it looks. It's like, oh my God, there's all that stuff there, right? It's not as bad as it looks. You just need to do one step at a time. So make sure you write this stuff down. You got your piece of paper out? Yeah. You know what? You're good? I'm going to trust you. Who do you guys play on Friday? Man, well.
100 points. You can play fullback.
If yeah, that's okay. So there are a number of steps to go through, right? It's not hard. It's just involved. So what's the first? Okay, the first thing we should do is figure out what the restriction is. So I need this for bracket x plus 2 to be greater than or equal to 0. So what can you say about x? So if you want, we can work this out. 4 times x plus 2 is greater than or equal to 0. We divide both sides by 4. It's nice. 0 divided by 4 is 0, right? 0 divided by anything. So we need x plus 2 to be greater than or equal to 0. So what do we say about x? Yeah. So x needs to be greater than or equal to -2. That's the restriction. Okay. So on the test, there could be a question that just says, what's the restriction on this? Not the solution, but what's the restriction? Okay. It usually be a multiple choice question, and then there's 4 answers, and you choose the correct one. Okay, what do we do first here? Add 3 to each side, right? So here's how we know. What do I do first? You think about this. If I gave you a value for x, said, forget this. If I just said x is 5, I want you to work this out for when x is 5. What would you do? You'd go 5 plus 2. You'd multiply it by 4. You would take the square root. Then you would divide it by 6. And then you would subtract 3. So in solving, we're going to do those in reverse order. So the first step is, the last thing I do is subtract 3. So the first thing I do is add 3 to both sides. So 1/6, the root. So everything else stays the same. Add 3 to both sides, and we've got it equal to 4. Okay, step 1. What's step 2? Multiply by 6. We multiply both sides by 6. So root of 4 times x plus 2 equals 24. Now, is the radical isolated? Yes. Right? Yeah, there's stuff going on underneath it, but there's nothing going on outside of it, right? So now what do? You square both sides. So 4 times x plus 2, right? When you square a square root, you just drop the root sign, drop the radical sign, is equal to 24 squared, which is what? 576. Okay, what's the next step? Divide both sides by 4, right? Okay, so x plus 2 is equal to 1 for what? 17, 4, 60, 144. So what's x? 142. Okay, is that good with our restriction? Yeah, okay, but we have to verify the solution. Verification, our left-hand side is 1/6. Remember, you always go back to the original, because if you made a mistake somewhere, if you made a mistake here, and you go back and stick it into one of the other lines, you're just going to verify your incorrect solution.
Can you just type it in your calculator if you don't want to type it out?
Well, this one says and verify, so we have to show it. Yeah. So, but if you were doing this for real, if you just said solve, then you could just do this by typing it in your calculator, right? So 1/6 the root of 4 times 142 plus 2 minus 3. So it's 4 times 144 minus 3. That's 576 minus 3. The root of 576 is 24, because we just did that. 1/6 of 24 is 4. And it comes down to be 1. Okay. So likely the solution is going to be right. Okay? As long as I don't have a radical that's equal to a negative, unless there's a negative in front of the radical. Right? So when you get the radical isolated, if you have the radical isolated and it's equal to a negative, you can stop there and say no solution since a radical is always positive. Okay? You don't have to work it out. Okay? Instead of solve, you just say no solution. Like this one is going to happen in a second. So what's the first step we do here? Minus 18. So 2 times the root of x minus 3 is equal to negative 8. So the root of x minus 3 is equal to negative 4. Now you could stop now, right? I'm going to continue it because this could happen to you on a test. You might just continue, right? If you're in a pattern, you're used to just working it out. But we could stop now and simply say, look, I've got a radical that's equal to a negative. A radical is always positive. I don't have a minus sign in front there. So if that had been like negative 2, it would be fine, because this would have divided out and made positive, we'd be okay. All right, but I'm going to solve it anyways and then verify it just so that we get a verification. We can say, hey, no, this didn't work. So I'm going to square both sides. There is no solution. I'm going to add 3 to both sides, and I've got my solution, right? I think x equals 19. And now I'm going to verify. And this is why you verify. Because this is harder to tell, right? That's just a 10. Right? So we don't know yet. Okay, looking at this, well, that's positive. Before you actually, as soon as you do this step, you can say, oh, yeah, it can't be. Right? There is no solution. But okay, so it's 2 root, and I've got 19 minus 3. No, it's too much of a root. Sorry. 19 minus 3 plus 18. And so far it's okay, right? Because I won't have a negative under the radical sign, right? Because, oh, what did we say the restriction is here? X has to be greater than or equal to 3, right? And it is, it's 19. Okay, so I've got 2 times 4 plus 18, which is 8 plus 18, which is 26. And that's when I say no. Right, I got 26, but it's supposed to be 10. So at this point, we write no solution. And on the test, legitimately, when you got to here, you could write down, since the radical must always be positive, there is no solution. Stop. Full marks. Right? So it won't be worth that many marks, right? Like this would be worth about 1 mark, because you just do a little rearrangement and you say, oh, it doesn't solve. So something like this, you might get a line that looks like this, solve these 3, it might be worth like 5 marks, so like 2 marks for the first one, and 2 marks for the last one, and 1 mark for the middle one. Okay, we got a cube root, so we know that on cube roots there is no restriction. So why am I writing that? X belongs to the reals. There'd be restriction if the x were down here, right? It couldn't be 0. But under a cube root sign, we are allowed positives, we are allowed negatives. It can be equal to a negative, that's fine, right? Because it's a cube root. Okay, what do we do to solve? First step, add 2. What's it equal to? -5. Like, I mean, I know this looks easy, right? It looks until you get on the test, and it's not so easy. So you need to do some practice on these, right? There's homework. Go through the homework. Do enough of them that you get confidence. Oh, it's a cube root. I know there's going to be a solution for a cube root. I just have to make sure if there's an x down here, it's not 0. Okay, what do we do to uncube? Cube it. How many qubits? How many qubits was the arc? What is a qubit? That's distance from your elbow to, that's a qubit. It's biblical. Okay, so x is equal to -50. Right? And then we're going to verify this. Left side. So the cube root of 5 times -50 over 2 minus 2. So that's -125 minus 2. Okay, and then it checks. Okay, again, if you're not asked to check it formally, then you can simply go back up here, go cube root on your calculator, go 5 times -50 divided by 2, hit enter, subtract 2, you got -7, it's all good. Okay. You could also solve any of these graphically, right? Put this into y1, put this into y2, find the x value. If you can't find an x value, so on this one, if you tried graphing this, you wouldn't find an x value. Right? Like that thing would not, those lines would not intersect. You could solve this graphically, they would intersect, right? When x was -50. Problem with doing it graphically is x is -50 and x is 142. Like you have no idea what it's going to look like and what your window is going to have to look like. So it's tough. We don't really want to do it graphically. A long time ago, in a land far, far away, the formula for the period of a pendulum was found by Galileo Galilei. This formula is shown below. T is equal to 2 pi times the square root of L over g, where L is the length of the pendulum and g is acceleration due to gravity. If it takes 2.5 seconds for one complete swing of a pendulum, then determine the length of the pendulum. Okay, so we have a formula. We're going to substitute into that formula. I'm going to try and remember what acceleration due to gravity. Some of you guys must take physics. What's acceleration due to gravity? 9.8 meters per second squared. 9.81. Is that at sea level? What about in Calgary? We're higher up. It might be lower. We would give it to you. Yes. Okay, so 2.5 seconds for one complete swing. So we know that t is 2.5. We're supposed to determine the length, so we don't know L, but we do know that G is 9.81. We're going to use 9.81.
Okay.
rounded value.
I
But.
don't know.
All right, how do we solve this? What do we have to do first?
Multiply by 2.
I would not multiply by 2.
Would you divide by 2?
I would divide by 2 pi. So, how do we isolate the radical? We get rid of this by doing what operation? Division. So 2.5 divided by 2 pi is equal to the square root of L over 9.81. Okay, is the radical now isolated? So what do we do? Square both sides. So I'm just going to write this as 2.5 over 2 pi squared is equal to L over 9.81. So what's L equal to?
Why did you square it?
Because we've been squaring it all day. And I thought, why stop now? Unless it's a cube root. We've isolated the radical, right? So how do we get rid of it? If it's a square root, we square it. If it's a cube root, we cube it, which is what? The distance from the tip of your finger to your elbow. Okay? So once you have the radical isolated, if it's a square root, you square both sides. If it's a cube root, you cube both sides. There's the calculation. So 9.81 times 2.5 divided by 2 pi all squared. So that needs to go in brackets. So everybody work it out. Everybody work it out. If you're going to get it wrong, do it now. Get it wrong now, and then we can figure out what you did wrong. All right, what have I got? 9.81 times root. Bracket 2. Oh, no, it's not the root. Clear. 9.81 times bracket 2.5. Okay, at least half of you are going to get this wrong. So you should be one of, so do it. Because if you're one of the half that's going to get it wrong, you want to know. Okay, so everybody needs to work this out because you're going to make a mistake. I almost guarantee it.
Did you get 227?
See, that's a mistake.
How did you know you just
Yeah,
did
1.5.
Because I know what I'm doing.
Oh, I did wrong.
Okay, so let's do it to the nearest hundredth. What's L? So to 2 decimal places. Who's got an answer?
15.21.
15.21 meters. Okay.
Is that what you know?
Anybody? Any other numbers?
38.57.
1.57 meters. Any other numbers?
150.
How much? 151? Or is that 1.51? 151?
I got 1.51.28.
Point. So 1.51 is the nearest hundred?
Yeah.
Oh, it's yeah.
Okay, so now here's what you do, right? You go back to here. You take the square root of your L divided by 9.81. You multiply that by 2 pi, and you see if you get 2.5. Okay? So you can just do this way, right? Just go second function square root. Go second function answer, right? That's L. Divided by 9.81 and hit enter. Then multiply that by 2 and then multiply that by pi. And if you get 2.5, then you were right.
Can't you just like get the answer for like the one side and then compare with the answer for the other side?
Well, that's what I'm doing.
Repeat that again.
Okay.
Isn't it? Isn't that what we're actually doing?
There's not one more side.
So the answer is really 1.55. 1.5530637768.
School had a 1.5.
1.55. So let me tell you how to get 1.55. It's none of these. Okay, so more than half of you got it wrong. So, okay, because we got to learn how to enter this in our calculator. That's why I told you get out your calculator and do it. So here's how you're going to enter it in your calculator, right? This is what we want to do. So I'm going to go 9.81 times bracket 2.5 divided by bracket 2 pi bracket squared. Now you'll get 1.55. Otherwise you won't. So here's what you did. You took 2.5, divided it by 2, and got 1.25, then multiplied that by pi, giving you something 1.25 times 3 going to like around 5 or something. Squaring that, getting 25, and then multiplying by about 10 and getting 250 or 150 something, whatever. Okay? So when you say divided by 2 pi, you notice the division bar, right? That means work out the top, which is kind of easy because it's just 2.5, but it says work out the bottom, then do the division. So I have to put this in brackets, right? It's divided by, I have to put that in brackets. So that I do 2.5 divided by whatever the result of 2 pi is. Then I square that, and then it multiplies. You're calculating Noah's order of operations, so if you didn't put, if you put it like this, it would go, okay, I'm going to go 2.5 divided by 2, multiply that by pi, then square it, then multiply it by 9.81. If you do this, it's going to say, I'm going to take 2 divided by pi, or sorry, 2 times pi. I'm going to go 2.5 divided by that, then square that, then multiply that by 9.81. Okay, and then you get the right answer. And we're done.